In this video, we're going to think about naming compounds. What that means is we are going to work on naming a compound such as sodium chloride or sodium bromate. We are going to combine the names of the elements from the periodic table as the cation with the anion names. So the first thing we want to think about is how do ionic compounds form? An ionic compound is formed between a metal and a nonmetal. So this would be something from the left side of the periodic table and something from the right side. And so we can see those across the board for most compounds that we are going to meet. As a reminder, we know that most elements have a predictable charge. So we'll talk about those first, then we will talk about things that are unpredictable. And so if you remember, and this is our periodic table, we go from +1 to +2, +3. This is +4, or occasionally -4, -3, -2, -1, and 0. So with those predictable charges, we are able to combine those together. Some compounds are going to be formed between a metal and a polyatomic, occasionally a polyatomic and a nonmetal, because there is a single polyatomic cation. And unless otherwise noted, this is really important, elements combine to form a neutral charge. So what that means is if you have an element with a 2 plus combining with a circle with, well, that looks like oxygen, so let's make that into a star. So if we have a star, that's a minus charge. In order to create a neutral compound, you would need 2 minus triangle with 2 stars, which should be a plus charge. So you would get a triangle star 2, where this subscript here tells you how many of something you have. And so we can look at the combinations between these for any set of elements or elements and compounds. So if we want to think about what compound would form between two elements, such as aluminum and oxygen, we need to ask ourselves one question. What are the predictable charges? So if we look at aluminum, it's in group 3, so that would give you aluminum 3 plus. And oxygen is in group 6, which means it's the 6th column over. So oxygen has a O2 minus charge. So we need to create a neutral molecule. So the question becomes how many aluminum ions and how many oxygen atoms in order to create a neutral compound. So I'm going to scroll this up a little bit so we have a little more space to work. So when we think about this, we need to figure out how many aluminums and how many oxygens would create a neutral charge. So there are a couple of ways that you can figure this out. Some students prefer to use the do-si-do reaction, where the charge here is the subscript here, and the charge here is the subscript here. So what that means is that you would have Al3 plus, Al3 plus, O2 minus, O2 minus, O2 minus. Together, those both add up to +6 or -6. And so what we'll see is aluminum 2, oxygen 3. So when we think about these components, that is a pretty good way how to think about how this combination works. So in the beginning of the video, we are going to think about how we form these compounds. At the end of the video, we're going to start talking about how we can name them. So for most of these, I would suggest that you figure out what the charges on the ions are, and then look at how we can balance those to create a neutral molecule or compound. And that's our real goal. So in this table, we want to be able to predict what the ionic formula is for this. So first, we're going to look at the periodic table and figure out what the charges are and how they formulate together. So for sodium and chlorine, we have Na plus and Cl minus. So because they're both a +1 or a -1 charge, those are going to combine together to give you NaCl, where you have one of each. We just did aluminum and oxygen, so let's do aluminum and chlorine. So aluminum, we just remember it is a 3 plus, and chlorine is a minus, which means we need 3 chlorines in order to balance the 3 plus charge. So it's aluminum chloride 3. where the subscript is the number of atoms. And so in this case, there are 3 chlorines for every 1 aluminum. So for magnesium and nitrogen, magnesium has a 2 plus charge, and nitrogen has a 3 minus charge. So we're going to look at the same balancing information, where how do we think about this? So in order to come to a neutral number, the closest neutral number is 6. So that requires 3 magnesium and 2 nitrogen. So all of the elements can have a subscript. In this case, we don't need parentheses or something else. And the subscript goes after the element of interest. So what about for calcium and iodine? So we're going to have calcium, which has a 2 plus, iodine has a single minus. And so in this case, we know that we're going to have 2 iodines for every 1 calcium, which gives you calcium I2. So the easiest way to do this is to think about how do these elements interact with one another. So let's look at some more examples. So in this case, now we're going to start thinking about polyatomic ions. So all of these ions came from the polyatomic ion table. More likely, we are going to need to remember the names and the charges. But in this case, as we're still learning this, I'm giving you their charges. So in this case, we know that sodium is Na plus, and sulfate, based on the information, is SO4 2 minus. So in this case, we know that there's 2 sodium, Na2, SO4. Now you might be tempted to write this Na2, open parentheses, SO4, but you don't need these parentheses because there's no subscript for the sodium sulfate. So this is unnecessary. So what about aluminum nitrate? So aluminum, Al has a 3 plus charge, and nitrate has an NO3 minus. So now we're going to need 3 nitrogens, or 3 nitrate molecules for every 1 aluminum. So our chemical formula is going to be aluminum, open parentheses, NO3, 3, where this 3 means there are 3 NO3 minus and only 1 aluminum. So the parentheses goes on the outside. We don't write, and I'll move this back in a second, Al N3O9, because this doesn't mean the same thing, where NO3 3 means that there are 3 of this polyatomic ion. So let's slide that back. Next, we have cesium acetate. So cesium has a +1 charge, and acetate also has a +1 charge. You might see other chemical formulas for acetate of C2H3O2 minus. Either one is fine. They are the same. So it's a 1-to-1, so we can write that out of CsCH3COO. And in this case, you could add Na parentheses if you wanted, but again, it's not necessary. So let's look at calcium dichromate. So calcium has a 2 plus charge, and dichromate is a Cr2O7 2 minus. So these interact in a 1-to-1, so you would write that as CaCr2O7. So whether you have a polyatomic, and so the only polyatomic cation is ammonia, which will be NH3, and so we can see that compound, and we will see it in other examples. But they interact the same way as they do whether it's 2 elements or elements and ions. So one of the things we also want to think about is how do we name compounds? So for a metal nonmetal, the metal is called by its name, meaning iron, calcium, etc. Basically what you see in the periodic table, which will contain names, is what you call it. So for a nonmetal, if it's just an element, it's the base name plus IDE. So what does this mean? So for oxygen, the base name is oxy, and so that would become which this changes to an I, so oxide. For calcium, nope, not calcium. For chlorine, chlor is the base name, so that becomes chloride. So for nonmetal single atoms, they change into oxide, chloride, fluoride, nitride. So when we have a metal and a polyatomic ion, they both go by their names. So in this case, if we were to have sodium nitrate, NaNO3, this is called sodium, and this is nitrate. There is one called nitrite, and we will look at that. Or you can look at that in your polyatomic ion table. So in this case, so far, we've really only thought about compounds formed between main group elements, meaning groups 1 through 8. The transition metals behave like metals, but what makes them unique is that they can often have more than one charge, i.e., they can transition between different charge states. So for example, iron can have Fe2 plus and Fe3 plus. So in this case, if we were to interact that with oxygen, with the oxide ion, so we have an O2 minus, we're going to get two different chemical formulas. We're going to get FeO and Fe2O3. So we need a way, because they both would be named iron oxide. And so we need a way how to tell these apart because they have different properties. So it turns out that we are going to name them according to the charge on the cation. So it would be iron, and then in here we'll go the charge. So it would be iron 2 or iron 3. If you're remembering on the polyatomic sheet or in other sources that some things have other names, such as ferrous or ferric. One way that previously people distinguished would say ferric oxide and ferrous oxide. However, it is easier to think about them using the charges. So for a transition metal, it is the metal, then the charge, then the nonmetal. And this, in fact, does not have a parentheses. It's the nonmetal or the polyatomic. Also not with a parentheses, I'm just using one to show. So this charge can come from the name. So if we named something zinc 2 chloride, you would know that the zinc ion has a zinc 2 plus charge and the chloride ion has a 1 minus charge. So the chemical formula would be zinc Cl2. We could calculate it that way. The other way we could generate this, because we want to be able to go from chemical formula to name and name to formula, like we'll see on the next slide. So what we want to note is that you could also go backwards. So if instead we had manganese nitride, so let's do a different example. Let's do manganese oxide. So we can look at this and we know that oxygen has an O2 minus charge. Because we know the ratio of these of 1 to 1, that means that this has to have a 2 plus charge. So it would be manganese 2 oxide. When you type these out, sometimes there is a space here and sometimes there isn't. Your homework system will require you to not use a space there. I will not have a problem either way. So let's look at some examples of naming and going back and forth between the formula and the chemical name. So here is chemical formulas on the right, chemical names on the left. So at this point, you should be using both the polyatomic table and your periodic table. As we move forward in the semester, you're going to want to be able to just know what the answers are. So Au is gold. And so what is the charge on gold? Because it's a transition metal. So we know that the sulfite ion is SO3 2 minus. So that means it has to be gold 2 plus. So we're going to have gold 2 sulfite. So the next one is sodium sulfite name. So we know that sodium is Na plus and sulfate is SO4 2 minus, which means we have to have 2 sodium ions to balance out. So Na2SO4. Now, if you want to, you could pause the video and try to complete the rest of this table on your own. And then I will talk through the answers. Otherwise, you can continue to watch along. So we have gallium sulfide. So gallium is Ga3 plus, and sulfide is S2 minus. And so don't forget that this is different than sulfite or sulfate. So in this case, we need to look at our do-si-do, where we look at the two charges and know that gallium 2s3 is the correct formula. So next, we have an iron phosphate. So the phosphate ion is a PO4 3 minus. And so the iron in this case, because they're 1-to-1, has to be Fe3 plus, which means we would write it as iron 3 phosphate. So for transition metals, we would never give you a transition metal and just hope that you could figure it out. You could either go from the chemical formula or from the name. We won't ask you to determine how does molybdenum and an element combine without giving you that information. So cobalt 2 nitride. So this means that it is cobalt 2 plus, and the nitride ion is N3 minus. So again, they're going to combine in a CO3 N2 mechanism. So for MoNO3 3, we have NO3 minus, and there are 3 of those. So that gives the molybdenum a 3 plus charge. So molybdenum 3 nitrate, sorry. And so the next one is strontium and Br2, which is Br minus, and Sr2 plus. But strontium is a main group element, so we don't include the charge inside the name. So it would just be strontium bromide. Sorry about that extra letter that I will erase. So next is nickel chlorate. So the chlorate ion is ClO3 minus. And we know that the nickel has a 3 plus charge, which means we need 3 chlorate ions. So NiClO3, 3. So when we look at these, the way we want to think about it is that they can come in this way. So the chemical name and the chemical formula tell you about how they are combined. So it's important to note that some compounds we'll see throughout the semester come with water attached. And so the water attached would be something like this. The CuSO4 dot 5H2O. So this means that for every copper sulfate, which in this case we're going to make green, so we have 1 green atom, then we will have 1, 2, 3, 4, 5 water elements. So this is something called a hydrate. And these compounds allow the copper sulfate, which maybe isn't as soluble, to be solubilized and dissolved in water. So when we think about the mass of compounds, which we will look at in a later video, we need to account that this just means connected, not multiplication. So it's not 1 copper sulfate multiplied by 5. It is that for every 1 copper sulfate you have 5. So if you were to name this, it would be copper 2 sulfate heptahydrate, where this means 5. So if we were to have a molecular compound is something thinking about if we have H2O or Ni3. So a molecular compound, don't forget, is a nonmetal added to a nonmetal. And so what we are going to use are slightly different prefixes. So we're going to use prefixes that tell you numerical values. So the prefix is how many of something else. So in general, we're going to have let's make this look a little different so that it's a little clearer. So in both of these squares are going to be the prefix. Things like mono, di, tri, etc. We don't really go above 10, and that would be deca. So both of these would have prefixes. The element behaving as the cation goes by the element name. The element going as the anion is named similarly to an ionic compound. For the chemical we routinely call water, if you were to give it its given name, it would be di, meaning 2, hydrogen, monoxide. And the dot in the middle is irrelevant, so I'm going to erase that. I just put it there. So next, if we look at Ni3, so we don't need to use the mono prefix if it's the first element. So in this case, it would be nitrogen triiodide. And so you could do this for any given compound. So if you look in the slide deck, the last slide is a summary table that allows you to think about how do we name things. And so you can practice naming using that spreadsheet where it says, okay, do you have a metal plus a nonmetal? Do you have a nonmetal nonmetal? And it will give you lots of tips. So this is how we can name different compounds, whether they are molecular or ionic.